Hello everyone, meteorologist First Weather here, aka Rohan Shroff. It is February 16, 2025, and we have a active weather week for the region here over the next few days. Let's get started. So this is the first kind of map right here showing the weather conditions across the lower 48. We had some very windy conditions for the mid-Atlantic today. Winds gusting up to 50 to 60 miles per hour for many regions. Power outages have been a big concern for areas in northern Virginia as well. And that's all due to a big area of low pressure up in the northeast. And that's driving down a tight pressure gradient with high pressure to the east or to the west, excuse me, and so we have a really tight pressure gradient funneling in those winds and also that cold air. And so this is that cold air injection. With as that low occludes and rapidly strengthens and deepens and heads off to Newfoundland, that's going to funnel in a lot of cold air from Canada right into the lower 48, and that sets the stage for upcoming winter storm in just a few days here. So if we take a look here as we go through time, we can see that as we go through the afternoon on Monday, we have calm conditions in place, high pressure over the area, so relatively quiet conditions, no precipitation to worry about. But as we get further through time, that upper level low and that Arctic air really starts to strengthen and dive further south in the Midwest, and that will be timed with a shortwave in the western United States. And as those features interact, that will set the stage for our next winter weather event for Wednesday into Thursday. Now, there have been a lot of changes with the system. As you can see, this is the WPC thoughts on it right now. This is, again, using a bit of older data. Recent model guidance has really kind of toned down the upward extent and amplification of the storm. And so a lot of people in the Northeast and, New York City to Boston have been really disappointed as the European model was showing, 1 to 2 feet of snow just a couple days ago, and it now shows pretty much nothing, right? So there's been a lot of model volatility, and it's all been because of the upper level low associated with our Arctic outbreak or that Arctic mass just to our north and west. And so, how those two features interact, the upper level low and the short wave, is going to be key in determining who sees the most snow and how much of it. And so, the past 24 hours, we've seen a trend that's less amplified, further south. Snow totals being really kind of south and east of Richmond to south and east of DC. New York City gets grazed by it. Philadelphia is on the northern fringe of it. But we still have 48 hours left to see what happens here. So a lot of time remaining to see exactly what occurs. Let's take a look here at the Weather Prediction Center's day 4 snowfall probability for exceeding 0.25 inches of precip equivalent. And as you can see here, they have kind of reflected that changing model consensus. Their highest region of probability for seeing snowfall in more than 2.5 inches is along Richmond, along I-64, down into the Delmarva, central Virginia, northern North Carolina, just northwest of Hampton Roads, and extending down into southern New Jersey with a tight gradient. Southeast of that, you have sleet, warm air, causing mixing issues, and then northwest of that, you have a very tight shutoff gradient with the convergence, the confluence to our north, hampering in dry air, and also the upper level low, basically shunting the storm to the east instead of northeast. So just a zoomed in look here, this is the same map. As you can see, the highest probabilities are right over the city of Richmond right now. This, of course, will change as we get closer to the storm, as models get a better idea, get a better sample of the upper air as that system comes through. But right now, I think you're in a good spot if you're, at Richmond and points south and east. For Northern Virginia, I think right now the trends definitely are not too favorable. But again, if you're along and east of I-95 in Virginia, I think you're in a really good position. Delaware, the southern portions of Maryland, southern New Jersey, right now are in a good spot to see a significant winter weather system, at least for now. So let's take a look here at the European model. This model was really getting a lot of people excited, especially in New England on Thursday and Friday. Again, showing 1 to 2 feet snowfall totals for New York, Boston, a classic KU snowstorm event, and that got a lot of people very riled up. And that, of course, made people, myself included, quite disappointed when the model very quickly backed off those trends today and into yesterday. And so what was causing that? Well, before we get into that, let's first take a look at the European here for the latest one. This is the 12Z February 14th model run, just to give you an idea of what it was showing. So this is 18Z Wednesday, the system's off the coast of Georgia. And then it interacts and phases with the upper level low, which is at a negative tilt, causing it to rapidly deepen and amplify, and that pretty much creates a full-on blizzard for portions of Virginia, Pennsylvania, New Jersey, New York, and that dumps a significant amount of snowfall for basically the entire I-95 corridor. But then as we go through time, we see the trend of the model. This is the 12Z February, or the 18Z February 14 run. This is the 0Z February 15th. And you can see the model gradually gets less amplified and further off the coast. So that shifts the snowfall maximum to areas east of I-95. And so what's the reason for that? Well, it's all in the upper level low and the kicker system to our west. So this shortwave right here on the western coast essentially prevents the upper level low from really obtaining a neutral tilt and sort of diving south. And that prevents the upper level low then from interacting in a favorable manner with our shortwave. So if we look here at the 12Z February 16th run from the European model, the latest one, you'll see, so this is our shortwave right here. Let me get my pen out. See if I can get a marker. Let's see. Do this. So this right here is our shortwave, right? So this is 12Z, Tuesday, February 18th, so a couple of days before the storm. That is in the western part of the country. Now this upper level low is the secondary piece. How these two features interact determines what type of storm you see. And then this right here is your injection of cold air. So that big low that went off the coast, that causes all the cold air to fill in behind it, and that sets the stage then for an ideal setup for a winter storm. The problem is you have that short wave on the western coast allowing for destructive interference, right? So if we look at the 12Z run right now, you see we have the upper level low, it spins in place, and it kind of almost tries to grab the short wave. The short wave is just a bit too much ahead, and the upper level low is just a bit too far behind, and it has just a touch of a negative tilt. So if we look at the tilt, it's sort of like this, right? Or you might want to make the argument that's even like this, but it's not negatively tilted like this, or it's not further south enough even, where it can really kind of interact with the short wave right here. And that's the issue. If we go back multiple runs, so if we keep on going back, we can see when the storm was much more favorable. So if we go to the, let's say 12Z Friday run, notice how the upper level low is completely neutral. It is stronger, more defined. It is closer to the shortwave, and it is a bit further west. So if we go to the most recent run, you can see while it is actually further east in this case, it's completely negatively tilted. Look at the negative tilt on that low. And that essentially makes the storm go straight east instead of pulling up the coast. So if your upper level low was tilted this way, this would cause rapid amplification, rapid deepening of your low, and the low pressure would go right up the coast, and you'd see a big snow for I-95. And unfortunately, the European model for snow lovers has not trended in that direction. You can see here with the 12Z run, you're at a negative tilt. If you go back further west, it is at a neutral tilt. The shortwave has caught up to it. The kicker system was a bit weaker, more disjointed, so that prevented that destructive interference, and that allowed for a major snowstorm then to hit the eastern coast, right? And so this is also reflected here in the QPF. Just to give you an idea of how much the system has de-amplified over time, let me just go through time. This is from the 0Z February 15th run, and as you go to the most recent run, you can see how the QPF slides from here all the way to the Richmond and I-95 corridor. So, oh, that's not what I wanted. Let's go back. There we go. So this right here is the 0Z February 15th run, right? Shows almost an inch of QPF in Charlottesville. That would be a 10 to 15 inch snow with the high snow ratios. And then as you get closer, now it shows about 0.5, maybe even 0.3 inches of QPF in Charlottesville and an inch of QPF in Virginia Beach. So this run would have a foot of snow on the coastline, believe it or not. So that is a very abrupt and significant change in just the past 24 to 48 hours. And again, with upper level lows, the modeling is always very chaotic. It's hard to get a sound understanding of how the features will interact. And so while it's not out of the realm of possibility that this changes or you see the trends reverse a little bit, I definitely do think that the chance of seeing a major, I-95 snowstorm from DC to Boston is almost slim to none now. The model trends have, become a bit more into agreement. You're getting closer to the event now where you don't really have that much space to suddenly go back to this being a major KU snowstorm. Yes, there is room for this to trend a bit back northwest, put higher QPF in areas like DC, Charlottesville, maybe even Philly and the fringes of New York. But this by no means is going to be a major snowstorm. That's just the facts. And that's supported now by the ensembles as well. If we take a look here at the EPS ensemble, actually I have it right here, I'll go back to that. This right here, if we take a look at the 500 millibar vorticity map, this is for 12Z Thursday, February 20th. And so what immediately sticks out here is two things. Number one, you have the shortwave to our west. This serves as a kicker, essentially, preventing this system from amplifying and strengthening up the coast. Instead, this basically makes it go due east. The negative tilt of the upper level low, which in part is due to the shortwave here, also prevents amplification, so you have a weaker low, it's off the coast, and it goes like this. And so again, as you would expect, that makes the heaviest snows pretty much along and east of I-95. So instead of seeing your big snows like this, you see a much smaller region and it being a bit further east. Now again, there is room for this to change. Just a couple, changes here and there by 50 to 100 miles on the upper level map would mean a dramatically different outcome. All we need over the next 48 hours is for this upper level low to go just about here and for the tilt to just go like this. And then you have a significant snowstorm for much of the region. Will that happen? I think right now, more likely than not, it will not. I do think, however, there is room for a bit of a northwest trend where we see the heaviest snow shift from here rather and instead go more like this, right? And again, that is one possibility. It's also another possibility that the kicker here continues to strengthen, the upper level low continues to become more positively tilted, and your area of maximum snowfall even goes further south, where areas of the coastline just get skirted, and inland areas get almost nothing. That's also a possibility. And I think we'll have a really good idea by about tomorrow at the 12Z model guidance. By then, the model should be in good agreement. We should have more data sampling, and we should have a much better idea of exactly who will get the most snow and how much that snow will be. And so you might have heard a lot of chatter over the past few days, including myself, who are very optimistic about this being a significant snowstorm. I was pretty convinced after seeing 3-4 runs in the Euro, dumping a foot of snow over the Mid-Atlantic and the coastal sections of New England. It looked like a pretty good lock that a major snowstorm was on the way. However, as the trend has been this winter, the trend has been for a more progressive and flatter look as you get closer to the system. That sometimes is a trend with La Nina winters, and it's also just about how sometimes things go during a particular winter. We have a very strong sort of TPV centered right over the Hudson Bay that kind of squishes systems, prevents digging and amplification. But at the initial look, if you show this picture to me, randomly, I would get very excited saying this is a very good pattern for snowstorms. And why is that? First of all, we have strong blocking, right? Strong negative NAO, injecting the cold air into the lower 48. You have the upper level low right here. You have an active southern stream, so that storm can then track, dig, and amplify off the southern wave. You have a positive PNA, so ridging on the west coast, allowing for that short wave and the upper level low here to dig and obtain neutral or negative tilt. You have a sort of 50-50 low here from our previous system, injecting that cold air in, preventing that system from really just sliding out to sea. And so on a broad-based look, when you look at the upper pattern, this pattern is very sort of, it's a classic KU snowstorm pattern. Now again, just because this synoptic pattern is, favorable for KU snowstorms doesn't exactly mean one will necessarily happen. Out of your, ensemble analog set of all the top 10 snowstorms, and this is kind of a similar map that's produced, There's also events that just barely missed, right, from being that huge snowstorm, and this looks like likely it's going to be one of them, where you have the ingredients in place, but the timing of the short wave, the timing of the upper level low are just a bit off, where you don't see that major I-95 snowstorm up and down the eastern seaboard. Now, however, there are a couple things that are in snow lovers' favor, and one of those is the injection of cold air. This is going to be an unusually cold snow event where it does in fact snow. This is the GFS model forecast for 18Z Wednesday, February 19th, and you can see high temperatures while it is snowing are going to be in the low to mid 20s. That promotes very high snow to liquid ratios, so you can throw out the 10-to-1 snow ratios. This is going to be more like a 15-to-1, a 14-to-1 snow ratio for a large portion of the area because of those temperatures. If we look at a sample sounding over the Richmond area, you can see that we have more than adequate cold surface temps. You have a pretty saturated DGZ, which is impressively deep from about 700 to 500 millibars. You have saturation throughout your entire column, and you have lift in your DGZ. So that all promotes, dendritic, productive snowfall growth in that DGZ region, and that would help to favor very efficient snowfall growth. However, if your system gets too weak, which has been the trend recently for a further south and a less amplified system, that reduces your lift in the DGZ. And so that would reduce the saturation a little bit, that would reduce the amount of lifting taking place, and that would then also cut down on your snowfall total. So snow to liquid ratios or SLRs are not based purely on your temperature. It's also based on the dynamics of your storm system. How much energy do you have in the atmosphere to really kind of harness the cold temperatures? It all has to kind of come together. But if the storm system can kind of maintain what its current forecasted strength is to be, if it can even strengthen a little bit, areas that do see snow will see pretty impressive snow to liquid ratios of 14 or 15-to-1. Now, if we switch gears here to the national blend of models, this kind of can give you forecasters a good idea of where there is model consensus or the average of all the models on where or what snowfall accumulations will be like. Now, keep in mind, I think this is a bit overdone as of now. I would like to see a couple more model cycles of favorable trends of that system maintaining its strength, because for the past 5 or 6 runs now, we've seen the system losing its strength, where models have a weaker system, a more positively tilted upper level low. So I want to see a couple more runs of this to really kind of get confident. But I like the idea of the placement of the snow. I think areas south of DC, especially from Richmond, points south and east, up until southern Maryland, up into southern New Jersey, that's where you have the shot for really seeing the highest snowfall totals. I think it's not another question that if the storm system can kind of maintain its predicted strength and it doesn't weaken further on the model projections, that some areas could see close to a foot of snow. Right now, I think that area is somewhere between Richmond and Virginia Beach. Could that change? Yes, it definitely could change, but that's where I see it right now. And of course, I'll tweet updates on my Twitter account for when and where that changes. And you can see here that pretty much once you get north and west of DC, there is a very tight cutoff in the snowfall totals. And you go to about Winchester, Virginia, and it's about 3 or 4 inches. So you can see very clearly that there is a sharp cutoff of the system because it can't amplify. So you have a sort of due east orientation with this, and that prevents your snow shield from really expanding north of I-95. Now we can also take a look here at snowfall ratios. So I can pull up the SREF and get the snowfall ratios here. Oh, it's in the CONUS actually. So if we look here at the snow to liquid ratios and we go to just about Thursday 7 a.m. Look at these ratios, right? 16-to-1, 17-to-1 snowfall ratios for the Mid-Atlantic. And so any areas that do see snow will see very efficient snowfall growth, right? If you see 0.3 inches of QPF, that's not going to be 3 inches of snow. That's going to be about 5 to 6 inches of snow instead, because of how cold the atmosphere is, because of your DGZ depth, etc. So I think there is definitely potential that if the system can amplify a little bit. The upper level low can achieve a more neutral and maybe negative tilt. You would see that snow shield expand, and you would see that snowfall then be pretty impressive then for large areas of the Mid-Atlantic. This right here, as we close, is the GFS ensemble for snowfall. This is the 18Z GFS run. And I think right now it has a relatively good idea. Earlier this morning, the maximum snowfall was even further northwest. So those models are continuing to trend more and more southeast. And so it bears monitoring. How much longer does this weaker and south and east trend continue? Because if it doesn't stop, these snowfall maximums will be out to sea. So really right now the thing is there is a lot of uncertainty. We're only about 48 to 72 hours out from the system, but with the way it's been with the upper level low and the complex interactions we're seeing, we won't really have a firm grasp up until maybe about 12Z tomorrow with the model guidance, or even a bit later. And so it just is sort of that wait and see type of thing. The ensembles have been back and forth. They haven't really been giving much clarity. But just to summarize here, what is the key? What are the key features? Number one, it is the upper level low here. How quickly can this upper level low achieve neutral tilt? And how will it interact with a shortwave in the southeast? And number two is the kicker system to the west in California. How strong will this be, and how much will it destructively interfere with the upper level low in the Midwest? Those two key questions are going to be key to seeing who gets how much snow and where, essentially. The past 4 model cycles have been for south and east and weaker. It remains to be seen whether that'll shift, and I just want to kind of emphasize here before I close this video is that we are very close. The upper level map at 500 millibars is not reflective of the surface. You look at the surface QPF and the precip type out the maps, and you would say, oh, this system is completely over. But when you look at 500 millibars, it is a pinprick away from suddenly becoming a more expansive system, a bigger snow for areas like DC, maybe Philly. But it remains to be seen if that trend will happen, or if the current trend will even stop. So again, it's a kind of a wait and see type of thing. We'll have a much better idea by tomorrow. But right now, again, if you're in essentially south of DC into Richmond, Virginia Beach, I think that's where you're in a really good area right now, in this region right around here. I think that's a good spot to be right now. So stay tuned for updates. I hope you enjoyed this video, and I'll see you next time.